Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we will solve a problem on Pelton wheel. So in our last lecture, we have discussed the efficiency and work done of Pelton turbine or Pelton wheel. So based on that equation, based on that formula, we'll solve this problem. So here I have taken a question that a Pelton wheel has a mean bucket speed of 10 meter per second with a jet of water flowing at the rate of 700 liter per second under a head of 30 meter. The bucket deflects the jet through an angle of 160 degree. Calculate the power given by the water to the runner and the hydraulic efficiency of the turbine. Assume that the coefficient of velocity is 0.98. So based on that, here I have taken this diagram from the book. So this is the bucket is there, and the jet is striking to the bucket at the middle of this center of this bucket, and here this is the, like, when it strikes the middle of this is called splitter, and the water will be goes out from the outside from this blade, like by covering this surface. Okay, so first of all, we will see what are the data are given in this question, then we'll go for the solution. Anyway, in the solution, first of all, we need to write the data given. In the first line, you can see the Pelton wheel has a mean bucket speed of 10 meter per second. So first one we can write, this is speed of bucket. So speed of bucket is nothing but speed of the vane or speed of the blade, which is denoted by U, small u, or you can write this is U1 and U2 for the inlet and outlet conditions. This is 10 meter per second. Similarly, which is flowing, the water is flowing at the rate of 700 liter per second. So here we can write this is the rate of flow. Here we can write this is rate of flow, or we can mention the discharge also. So this is Q equal to, here you can write this is 700 liter per second given. Liter per second we can convert into meter cube per second. So meter cube per second, if you convert, just to divide into 1000, so you'll get 0.7 meter cube per second. And this is under a head of, so under a head of, in the sense h equal to, here it is given 30 meter. Okay, head of water, this is 30 meter, and the bucket is deflected with an angle of 60 degree. So this bucket, okay, this bucket deflection, in the sense the bucket deflects the jet through an angle. So the bucket here, this is the bucket, and which makes an angle of 160 degree up to this one. Okay, so when the deflection angle given here, so you can write the angle of deflection given. Okay, the angle of deflection is given 160 degree, and next we can write what is the angle of this. Now if you see, the angle of this is phi. Okay, the relative velocity. Now if you draw this one angle, so here it is given 160 degree, correct? So this angle is equal to this angle. So to find out this angle is given how much? 160, as I told you. Total angle is 180 minus 160, that is 20 degree. So here I can write the angle of phi equal to 180 degree minus 160 degree is equal to 20 degree. Now the next one, coefficient of velocity is given. So coefficient of velocity CV is given 0.98. So these are the data given in the question. Now the next thing is we need to find out the we need to do the calculation for this. So what we need to calculate in this question? The calculation always will be given in the last of the question, or sometimes it will be in the middle and the initial also, but mostly it will give in the last. Calculate, the first one is power given by the water to the runner. So, and the hydraulic efficiency of the turbine. So first one, the power by the water to the runner. So power we already have calculated in our last lecture. So this equal to work done per second divided by 1000, actually this much kilowatt. So what is that work done per second? We got this work done per second is nothing but rho a V1 into VW1 plus VW2 bracket close into U divided by 1000. And second one is nothing but efficiency, hydraulic efficiency. So hydraulic efficiency, we have seen that output by input. And finally, by solving that one, we got this equation. This is 2 into VW1 plus VW2 bracket close and divided by this is V1 square into U is there in the top. So this is our formula for the efficiency. Now, if you see in this equation, what are the unknowns are there? Rho, area, V1, VW1, VW1. Everything is unknown here. Only U is given in our question. Remaining all things are unknown here. Now, first thing I can identify the value of rho. So let me first write down the rho. Rho is nothing but density of fluid. So fluid we have taken here water. So rho of water, density of water is nothing but 1000 kg per meter cube. Similarly, area of the jet in the sense that what is the area of this jet is giving a force to this one blade. So area can be calculated from the discharge, because discharge equal to area into velocity. So once I calculate the value of velocity, I can calculate the value of area. So now we need to find out the value of V1. So here you can see V1 for the inlet condition, if you see V1 equal to VW1, and at outlet condition different. This is VW2. So VW2, VW1 we need to calculate. So V1 if I calculate, I can get the value of VW1. Both are same. And okay, so let's first find out the value of V1. V1 equal to the velocity of jet, and that can be calculated with the formula of CV into root over of 2GH. Okay, so CV equal to 0.98, and this is into 2 into this is 9.81 into the head, this is 30. This equal to, I can write here, let me solve it. This is 2 into 9.81 into 30, root over of this again multiply 0.98, 23.77. so here we got the value 23.77 meter per second, and this equal to this V1 equal to VW1. This is equal to VW1. Now, yeah, some assumptions we need to consider. Assumption not, we need to, it is correct only. VR1 equal to VR2, VR1 equal to VR2, and VW1 equal to V1 also I have written. Now here I can write VR1 equal to V1 minus E1. If you see, this is V1 value, correct? VR1 value, relative velocity. So total velocity minus E1, if I subtract it, I'll get the value of VR1, because both values are there with us. So here V1 already we have calculated 23.77 minus this is 10 equal to, I can write this is 13.77 meter per second. This is called VR1, and which is nothing but I can write VR2. Okay, VR2. So VR2 also we can write this value. Okay, now we got the value of VW1. Now we need to find out the VW2. So VW2 here, let's find out. Okay, let's see here. This is VW2. VW2 equal to this one I need to find out. So what I can write? So VW2, to find out this one, I'll take this velocity component of this relative velocity at the outlet condition. This equal to VR2 cos phi, and this equal to this one minus this. So I can write this is VR2, this is cos phi minus U2. This one I can write. Now here VR2 equal to, this is 13.77 into cos 20 degree minus U2. U2 is nothing but 10. So here we can find out the value of VW2. So let's find out. Yeah, first 20, trigonometry of cos 20 into 13.77 equal to minus 10, 2.93 or 2.94 we can write. So this one we got here 2.94 meter per second. So here we need to find out the first one. This is our power required. So power equal to, I can, as I told you, this one divided by 1000. So here what I'll write this formula 1000. Yeah, one more is the area. So area also can be calculated here, like area equal to, as I told you, Q by V1. So Q equal to, this is 0.7 and V1 equal to, already we have found here, this is 23.77. So I'll do one thing. This is 0.7 divided by 23.77, 0.0294. This is equal to 0.0294. This must meter square is there. Okay. Now let me write this 0.0294 area into VW1. VW1 equal to how much? So VW1 equal to 23.77 because it is equal to the V1 plus 2.94. This is VW2 and this is bracket close into U. U is nothing but 10 and this one divided by 1000. I can cancel this. So let me find out. Okay, this much multiply 10 and multiply bracket close 23.77 plus 2.94 bracket close 7.86. Okay, we got the value here 7.86. Yeah, everything is correct, I hope. 0.0294. Yeah, okay, area to, okay, one more velocity is there. Okay, multiply 23.77. Yeah, 186.97. I'll tell you what I have missed. 186.97, this much kilowatt. Actually here if you see, one V1 is there, that one we have not written, so that is nothing but 23.77 here. Okay, this 1000 is 1000 cancel and finally we got this power. This is the power given by the water to the runner. And the last one, the second question is given to us, that is hydraulic efficiency, and the formula already I have written there. So this is 2 into, again, bracket start, this is VW1, this is nothing but 23.77 plus VW2. Here also you can give a square bracket or normal bracket also can be written. And this is VW2, so VW2 is nothing but 2.94 into 10 divided by, this is our V1 square, that is 23.77 square. So this equal to, we can find out, yeah, let 23.77 plus 2.94 equal to into 10 into 2, 534. Yeah, 534.2. So let me write 534.2 and divided by, this is square. So I'll do one thing and divided by this one, 23.77 square. So this is 565 point something is there. Yeah, 001 actually. Now let's find out. Yeah, this is finally, this is 1 and this one we got 0.94 and 54. This is the efficiency. If I want to convert it into percentage, then I can write this one 0.94.54 percentage. Always keep in mind the Pelton turbine efficiency will be more than like 80 to 90% will be there, and this is our final answer. This is the efficiency and this is the power which is given by the water to the runner. So I hope you understand this problem, how to solve it. Still, if you're having any doubt and query regarding this, you can give a comment on the comments. Thank you all.